All right, motion of the ocean. We talked about currents. Let's talk about tides. Before we do, let's continue this mathematical journey of a super secret code. All right, take whatever your answer is so far, and then take the square root of that answer. So take whatever your answer is so far, put it in a calculator, the square root of that answer. We continue. So tides are another way in which water moves around. Instead of kind of more surface horizontally, tides are more kind of vertical, up and down. Generally, a tide rises twice daily. It's the rise and fall of sea level in a local area. And this is a natural occurrence. This is something different than climate change sea level rise. So tidal ranges vary around the world from 6 to 10 feet between, or average about 6 to 10 feet between high and low tide. So that's why if you've ever been to the ocean, the beach, you can go at one point of the day and the water is like kind of way far away from the beach, and then you go back, later in the day and the water's kind of closer to the beach. It's because the tides are rising. The world's largest tidal range is over 53 feet, and that occurs in the Bay of Fundy, putting the fun in Fundy, Bay of Fundy, Canada. So kind of located a little bit northeast of kind of most of Maine, so up in this area. So the Bay of Fundy, the further you gotta kind of get up into this area, the bigger the tides. Just has to deal with the geology, the how it narrows down, a number of different factors. But one part of the day could be like this. An hour or so later, you need a canoe to get through there. Here's another one. One part of the day, your boat could be on dry land. Another part of your day, your boat's floating in water. So why does all this occur? Why does this sea level change happen twice daily? So you get 2 high tides, 2 low tides. Most places. Sometimes you only get 1 high tide, 1 low tide. But why does this occur? Well, it has to deal with the Earth kind of spinning around, and it has to deal with the moon, and it has to deal with the sun. All right, so the sun and the moon, they have a gravitational attractive force, right? They're pulling on the Earth. Anything that has mass has an attractive force, anything. That's why when, we drop a pen, the Earth is pulling it down. It's attractive force. It's the pull of gravity. Well, the sun is obviously pulling on the Earth. Not only is it pulling on Earth, it's also pulling on the water. Well, same thing with the moon. Now, the moon's much smaller than the sun. The bigger an object, the more gravitational pull. So the moon's much smaller, but it's also pulling on the Earth and everything else on it, including the water. What's interesting is that the moon tends to have a much bigger influence on tides than the sun does, because the moon, even though it's smaller, it's closer. So the force of gravity not only has to do with how big objects are, but how close they are. So we got both both the moon and the sun pulling on Earth and everything else on it. So because of that, so the sun and the moon are pulling on the Earth, all right, kind of moving it to the left, but also the sun and the moon are also pulling on the water, so kind of stretching it out that way. So this would be something called a spring tide. When the sun and the moon and the Earth are all aligned, typically you're going to get the highest high tides and the lowest low tides. When the moon, Earth, and sun are at a kind of like a 90-degree angle, you kind of have opposing forces. The moon, although smaller, does have a bigger gravitational pull, so you're going to have a high tide and also low tides, but it's a lower high tide and a higher low tide. When that occurs, it's called a neap tide. We'll explain all that in just a minute. So with spring tides, you get high highs and low lows. So the highest of the high tides and the lowest of the low tides. Spring tides, it's named nothing to do with the season of spring, rather it's just the term because the tide is springing forth. You'll get the highest high tides and the lowest low tides, called a spring tide, twice each lunar month. So the moon has a 28-day cycle around the Earth. That's actually where the original term month came from, month. So each lunar cycle, which is 28 days, you'll have 2 spring tides, but you'll also have 2 neap tides. So this occurs when there's a full moon or a new moon. More on that as well. Neap tides are when you have low highs but high lows. So their high tides are kind of on the lower end of the spectrum, but the low tides are kind of as high as they will be. The origin of the word neap is kind of completely mysterious, so don't ask me about that one. They occur 7 days after a spring tide. So therefore, if a new moon and a full moon are when spring tides, 7 days adjusted from that are first and third quarter moons. It's when the moon looks half full. There's no such thing as a half moon because the moon is always half lit. It's just depending on what part we see. So in any case, new moon is when you don't see, there's no moon in the sky. Full moon, well, that's a full moon. So it's during these two that we would have a spring tide. 7 days from that would be a first quarter moon or a third quarter moon. This is when we would have neap tides. So the highest highs and the lowest lows, lowest highs and the highest lows, and then you have everything in between. So the cycle goes from new moon to waxing crescent, first quarter, waxing gibbous, full moon. Now the moon is appearing to shrink, so we have a waning gibbous, third quarter, waning crescent, new moon. 28 days. So from a new moon to first quarter, 7 days, 14 days, 21 days, 28 days. All right, so let's put all that together. So here's a, excuse me, here's a tide forecast for Miami, Florida. Kind of looking into the future, at least from when this is being made. So kind of looking here in the week of November 16th, 17th, 18th, you can see that these high tides are rather high, and they kind of dip down and then back up again. So we have the high tides, those are spring tides. We have where everything dips down, low high tides, but high low tides, those are neap tide. And then again, things high highs, low lows, you have a spring tide. All right. So interesting enough though, why is this spring tide higher than this spring tide? Well, all right, we're going to do a little astronomy, so just buckle in. The moon does not move around the Earth in a perfect circle. It's actually more of an ellipse, more kind of an oval. Now, this is a highly dramatized ellipse. It actually almost looks like a circle, but it's not. It's just a little squish. This is just kind of just to give you the idea. But the moon, since it has a bigger gravitational effect on tides than the sun, and proximity to two bodies, how close or how far away, has an effect on tides. When the moon is closest to the Earth, we call that perigee, you're going to get the high tides. When the moon is further away from the Earth, you're going to get lower high tides. That's called apogee. So when it's closer during a full moon, we call that a supermoon in perigee. And when the full moon is further away in apogee, it's a micromoon. It looks smaller. So that's why every once in a while you'll hear something called a supermoon. That means it's a full moon in perigee when the moon is closest to the Earth. Compared to when it's furthest, it appears 14% bigger and 30% brighter. Supermoon. Not only that, but the Earth also revolves around the sun in an elliptical pattern. It almost looks circular, but it's somewhat elliptical, shifted a little bit. Please ignore this. This is kind of cartoonish, just so you can get the idea of what's going on. But in January, the Earth is closest to the sun. That's perihelion. In July, the Earth is furthest from the sun, aphelion. So because of the elliptical pattern, and the differences in distance and how gravity differs with distance, that's what gives us variability to all tides. So again, January, for example, January of 2021, the Earth was in perihelion. July 5th, so 6 months later essentially, the Earth was in aphelion. New moons are when it's between the sun and the Earth. Full moons when it's on the opposite side of the Earth from the sun. So what about when this is being made, this video? Well, here's about November 9th, right? New moon and your full moon. So it looks like new moon is kind of pretty close to perigee, closest to the Earth. Full moon is getting further out, kind of closer to apogee. Let's put all this together, all right? So, coming up from, or right around when you're watching this lecture, depending on when that is, on November 19th, you will have a full moon, All right, so full moon. So I see that looks like a spring tide here. I have high highs, low lows, so we have a spring tide. But that is around when the moon is in apogee. So it's a full moon, so we're going to get a spring tide, but it's apogee when the moon is further away from the Earth. Therefore, the high tides won't be as high as another spring tide. So we get a smaller spring tide because the full moon is in apogee. Whereas in the beginning of December, we have a new moon. So remember, full moon or new moon is what we need for spring tides. But that's going to be in perigee. So the new moon, when it's closest to the Earth, so now we have a larger spring tide because the new moon is in perigee. So whether it's new or full, it doesn't really matter, but are those either apogee, far away, or perigee, closer? That's going to give you either the highest spring tides or kind of the lower spring tides. A lot to all put together. I know. Let it sink in. We'll touch on this a little bit in lab. I wouldn't ask you something so complicated in a test. Would I? Great example of tides. Another one is Mont Saint-Michel in northern France. This church built on this little rock kind of off the coast at low tides. You can actually drive over here, you can walk over here, you can visit. Kind of looks like a nice little town. But during high tides, no more road. It's blocked off from society. I like that. I want to live there. Just nope, blocked off from society. You got to wait for low tide. You got to wait 6 more hours. I like that. I like it a lot. All right, so we talked about tides. Or excuse me, we talked about currents, then we talked about in this video tides. So we'll talk about one more movement of the ocean. We'll talk about waves, and again with sea level rise. More on that in the assignment. So I'll see you back here in just a second.